Hi, welcome back to the tutorial series for Proximal One, an interactive audio system for Unreal Engine. This video might be a little bit longer because we're having a look at the LFOs and we've got a lot to talk about. Okay, so what is an LFO? An LFO, it stands for low frequency oscillator, and basically it's an oscillator that can be used to modulate variables such as the gain, a filter cutoff, and the pitch, and that's what we're going to be doing today. Okay, and we're going to be using it as well to generate a procedural melody. So let's have a look at this scene currently, what we've got. So over here I've got a drum track which is just looping over, and in this one I've got an audio, like a melodic kind of part that's just looping over as well. So if I hit play, we can have a listen to what's actually happening. So yeah, it's not too melodic, but we've got some sort of sustained sounds there that should help us hear what the LFO is actually doing when we apply it. Okay, so if I just hit stop again. So currently we're looking at the proximity fade visualizer, and when we're using the LFO to apply the gain, we can actually see that on this visualizer. So to enable that, with the instance selected, if you come down to visual components, and we just want to have this one ticked to show LFOs in filter or fade color visualizer. So I've got it ticked right now. So now with that out of the way, if we come down to where we've got LFO 1, we can see the settings that we've got in the LFO. So we've got two different LFOs. We've got LFO 1 and LFO 2, but they both do the same thing. So we just need to have a look at LFO 1. Okay, so the first setting we've got, LFO amount, basically controls the overall amount of all the sends. And what the sends are is this is the way that we enable the LFO to have an effect on the specific thing that we're sending it to. So for example, we've got filter 1 send, and that controls the cutoff of filter 1, and then we've got the same for filter 2, and then we've got gain, and then we've got pitch, and then we've got 1 which is for a custom metasound variable that you'd find in the metasound graph. So if I was to first, if we'll look at the gain first, because we've got this visualizer set up. So if I just increase the send to 1, we can now see that it's having an effect on that visualizer. So if you don't know, the green area in the visualizer, as it goes into amber and red, sort of shows you the active gain area. So where it's translucent is going to be where it's at its minimum value, and where it's red is going to be at its maximum value. So if I was to hit play now, we should be able to hear what that oscillator is doing to the gain. So let's try that. Okay, so I'm just going to reselect the instance, and we can have a play around with these settings. So let's just take that gain off for a sec. Now if I was to send it to filter 1 and add in a value of 1, a little bit hard to hear, and that's because our filter cutoff is quite high at the moment, and filter 1 is currently active to use a low pass filter. If I was to increase that number though, you can actually hear it starting to modulate a little bit more. So this is oscillating in octaves. So with a value of 4, it means it's going up an octave and then down an octave. So it's modulating across 8 octaves. Okay. So I'll just set that back to 0. We'll come back to filters. And now we've got this one as well, the pitch. So if I set that to a 1, we can hear that we're modulating the pitch. And so this is by an octave as well, so 1 octave. And that's important to know actually, because we're going to touch on that as well in a bit later on. But for now, I think we'll just keep it set to 0, and we're just going to play with the gain because we've got the visualizer active. So if I set that back to 1, hopefully the music's not too distracting. I have concern that in some of the other videos it might be. So I'll try and keep it to a reasonable level. So yeah, what else have we got? So we've got this one, LFO rate in hertz when free, and I'll come back to that in a moment actually. And first, if we were to just look at the LFO rate when synced, because it's currently synced. Currently our rate is set to a bar. So a bar is 4 beats, and you can see that it's oscillating on every bar. So we're getting 1 full cycle on each bar. And if I was to change that, so that's half a bar, which is 2 beats, and then we can set it to a quarter, which is on every beat. Okay. And if I was to actually untick sync LFO, let's untick it. So when that's not ticked, then it's going to use this rate here that's set here. So LFO 1 rate in hertz. So you can actually use that to increase it. So obviously it's not synced to anything, so it's able to just run free. Whereas when it is synced, it is synced to the quartz clock. Okay. So I'm going to turn the sync back on. And let's change it to something that's a little bit more off-grid. So we can try 1/4 dotted. So now it's playing a dotted note pattern, and it's going to keep oscillating like that, and it could start to sort of sound a little bit disjointed from the actual groove that we've got going on. So one thing that we can do is we can tick this, and then what that would do, it will reset the start position of the LFO. So if we tick it, then we've got this phase reset rate. So here we can set how frequently we want it to reset the phase. So currently every 2 bars it's going to restart that pattern, and you can see it's doing that. Okay, just going to just save this actually. I've got a diagram in Photoshop that I can use to explain that a little bit better, so let's go and have a look at that. So this would kind of be what a sine wave LFO would look like. If you could imagine that this is our timeline, and so we've got a bar here and then another bar here, and then we've got our oscillation here. So what phase reset would do, if it was set to 2 bars, it would reset the phase when it gets to this point. So the waveform would then look like this. You can see it's getting to here and then it's restarting the waveform. Okay, we'll come back to that diagram in a bit because I'm going to use it to explain the phase offset as well. But for now we'll just carry on looking at these settings, so I'll just hit play again. So after LFO1 rate, the next setting we've got is Randomize LFO1 rate. So if we were to tick that, what it's doing now is it's playing a random frequency at a random duration, and after that duration it will play another random frequency with another random duration. And this works by using an algorithm, and we can change it by changing the seed value. So this could be useful for creating a more organic feel, rather than having your LFO sort of synced to like a quarter note, for example. And we can also use the phase reset with this, so if we wanted that pattern to restart on every bar, we could do that. Or half a bar. Okay, you get the idea. So I'm just going to actually untick that for now, so we can have a look at what's next. So just untick that, and I'm going to change the LFO rate to half. So the next setting we've got is the LFO shape. So currently we're looking at a sine wave. If I press stop, if I just save this quickly, just stop it for a moment. So if we look at it from this angle, it might be a little bit easier. So yeah, currently you can see it's oscillating in a sine wave pattern, but we can change that to a sawtooth, and you can see how that responds. And we can change it to a triangle, so that just moves up and down in a sort of linear way. And we can also change it to a square wave, so the square wave sort of acts like a pulse on and off. And then we've got this setting, phase offset. So now would be a good time to have a look at that diagram again, so we can sort of understand what the phase offset's doing a little bit better. So looking at the waveform, so a complete wavelength would be from this point here to this point here. That's one oscillation. So if we were to offset the phase, essentially what we're doing is this. So from this point here to this point here would be 360 degrees, or in our case it would be 0 to 1. So if I was to move it to here, that would be 0.5, and this would be 1. Okay, so let's go back over to Unreal. So if we were to count the beats, 1, 2, 1, 2, 1, 2, we can see that that pulse is occurring on the second beat. But if we were to change the phase offset by 0.5, now we're seeing that it's occurring on the first beat. So hopefully that gives you an idea of what phase offset does. Now the next setting we've got is square wave pulse width. So what this does is it will just change the length of that pulse, so we can either decrease it or increase it. Okay, and we've also got a setting here which enables us to flip the phase upside down. So we've got two different ones for these. We've got one for the filters when we're using the sends for the filters, and we've got one for the gain. So let's try that. So you notice it's on the second beat at the moment. So if we flip the phase, now we've got it on the first beat. Okay, so the first 4 LFO shapes that I showed you are the ones that you can actually get in the Metasound graph using the LFO node. We've also got a one here called Random Step User Seed that's actually been built for this system. And let's just stop this for a moment actually. So when you're using the first 4, you'll be able to see these in the editor, but the 5th one, Random Step, you'll only actually be able to see this in the visualizer when you hit play, because it does require the Metasound to be playing. Okay, and that is actually the same for this setting, Randomize LFO 1 rate. You won't be able to see that in the editor because it requires the Metasound to be playing, because that information, because it's randomized, we can only get it from one source, whereas the other LFOs, these can be recreated in the material shader quite easily. So let's change that to Random Step, and then we can have a look at what this actually does. So you just hit play again. So what the Random Step does is it will pull random values from an array. So an array is just basically, it's like a list of variables. So currently it's the array that it's using is linear scale. So what linear scale means in this case is each value in the array is equally spaced apart from the value before and after it. Okay, so this uses a seed algorithm as well, and you can change the seed value down here. So you can see that we've got sequence seed 1, 2, 3 and 4. So we've got 4 different ones that we can have in a sequence. So currently we're just using the first one because of this setting here, number of seeds in the sequence. So when that's set to 1, it will just use this one. and here we can set seed value. So when it's set to control the gain with this random step setting, you can see actually that it's pulling out different gain values, and it's doing it using the LFO rate that we set up here. Okay, and we've got this setting here, use gain random step LFO1 as a gate. So if we were to tick that now, what that does, it will round off the values that it pulls out from that array to either a 0 or a 1, and we can change the probability here. So we pull that down, it's gonna output a 0 more frequently than a 1, or if we move it up we can output a 1 more frequently. So this could be useful if you wanted a randomized gated pattern, but for now I'm just gonna untick that actually, and we can have a look at the sequence and how this actually works. So yeah, currently we're just using the first seed in the sequence, but we've got this setting, seed re-trigger rate. So what this does, it's kind of like the phase reset, but for the algorithm pattern, the seed pattern if you like. So the seed pattern will generate random values, or it will pull random values out of that array in a pattern, and it will keep doing that indefinitely until you tell it to restart that sequence. So when it restarts that sequence, or should I say restarts that pattern, then that sequence of random values will repeat over again. So you can use it to get repeated patterns. Okay, so maybe if we were to change that to 1 bar, you can see that we're getting a repeating pattern. Okay, and the next one we've got is the seed duration. So what that means is when you're using the sequence, currently that's got to set to 2 bars. That means it's going to play each step in the sequence for 2 bars. So it would play this one for 2 bars, this one for 2 bars, this one for 2 bars, and this one for 2 bars, and then it will restart the sequence. So if we were to change that to a 4, now it's running through this sequence. But it might be a little bit hard to hear what it's actually doing when we're just controlling the gain. So with that in mind, we can have a play around with it and do something a little bit more interesting. So if I was to just change that back to a 1 just for now, I think, and I'm going to set that back to 2 bars and set that back to 0. And save this. I'm just going to stop it because we're going to actually use the pitch instead of the gain, and at this point we can now use this to generate a procedural melody. Okay, so I'm going to set the gain back to 0, and I'm going to set the pitch to 1. And also I'm going to change the audio sample. So the reason I'm going to change it is because I'm not actually sure what notes this is playing. I know it's in A minor, but it may be playing notes that aren't the root note. So we need a sound that is in the root note, so that when we detune it, we're detuning it to the scale that we're going to select. So we've got some sounds in the content browser, in the audio folder, under one shots that are just single note sounds. We can use these. If we were to loop these over, we could use that LFO to detune them. So if I just pick that one and assign it, and I'm gonna loop it on each beat. And actually, I just thought if I turn the pitch off so we can hear what it sounds like first without the pitch applied. So let's do that. Okay, so you can hear that we've just got that sound, a little bit annoying, but it's just that sound looping over. And actually, where we've got loop duration in beats, I might actually just change that to a half a beat. So now we've got this thing going on, it's looping over a little bit faster. So if I was to assign that pitch send to it, and let's just change that LFO rate because that's a little bit too fast. So you can hear now it's sort of playing random pitches, but it's not very musical. But if we come down to where we've got random step LFO 1 scale, we can change it from that linear setting and actually choose the scale that we're working in. And now it becomes a lot more musical. But because we haven't actually got any other tones playing apart from the drums, we can actually choose any scale that we want. So I'm going to try Phrygian dominant. It gives it a kind of more mystical, eerie feel. But that's a little bit, sounds a little bit crazy. So what else can we do with it? Well, actually, let's try adding a different seed value. So at this point, you've really just got to play around until you find something you like the sound of. Actually, we could try that. We could have seed 0 for, I don't know, like 4 bars, or yeah, we could do 4 bars and then change it to this one. Let's try this. But this is going to sound a little bit annoying after a while. Not very musical. I mean, it is playing a melody, but we can take this one step further. So one of the things that we can do is we can come up to the envelopes and enable ADSR, and we can set it to trigger from this LFO. So every time that value changes in the LFO, it's going to send out a trigger signal, and we can use that trigger signal to trigger this envelope. So we can untick this one, and play around with the release time. So now we've got some shorter notes. Just going to save that. But that could still be a little bit too much. So another thing that we can do, so we can come down to where we've got pattern sequence, and we can have a play around with this. So currently each of these is 2 bars, so that's it's going to be an 8-bar sequence at the moment. So how many beats are in 8 bars? Well, if we just I'm just trying to think. Let's just have a play around with it and see what we get out of it. So if we enable it, so it's a little bit less full on now. And now we can actually have a play around with the filters as well. So currently we've only used one LFO, so we just close that one. We can come into LFO 2 and maybe assign a filter. And this is where the Randomize LFO rate actually sounds quite good. And we can also change the filter cutoff. So under filter, general settings, and I'm actually just going to have a little play as well with the compression. And change it to upward compression. And we can bring it to life by adding a little bit of delay. And some reverb. So actually, if I just stop it now, actually, because I could sit here for hours and play around with that and you'd probably get bored. So hopefully you get an understanding now of what the LFOs can do in this system, and we'll just have a quick look and make sure I haven't missed anything out. So yeah, you could do what I just did just now and sort of create a melody, and then you could create another melody that goes alongside it. And then you could maybe duplicate that first melody and just tweak it a little bit, and then trigger that melody from another instance, like maybe the previous one could trigger it when the player leaves the collision box. Anyway, you can see how you can sort of create your own musical components and sort of use them to build up your own piece of music procedurally using that LFO system. But yeah, there's other uses for it as well. So for creating sound effects. So for an example, if you watch the proximity fade video, there's a good example of how we can use it to create a sound effect. But yeah, I think that covers it for this video. So if you've got any questions, just leave them in the comments and I'll try and get back to you. So yeah, hopefully you found that interesting, and I'll catch you in another video. Okay, cheers, thanks and bye.